अस्सलाम वालेकुम स्टूडेंट्स। आज हम लोग डिस्कस करेंगे फ्रीक्वेंसी मॉड्यूलेशन को। इससे पहले हम लोगों ने एम्पलीट्यूड मॉड्यूलेशन को डिस्कस किया था। फ्रीक्वेंसी मॉड्यूलेशन जो है ये एंगल मॉड्यूलेशन की टाइप है। एंगल मॉड्यूलेशन में हमारे पास फ्रीक्वेंसी मॉड्यूलेशन और फेज मॉड्यूलेशन दोनों होते हैं। एम्पलीट्यूड मॉड्यूलेशन में हम लोगों ने देखा था एम्पलीट्यूड ऑफ द वेव जो है, कैरियर वेव जो है, इट विल इंक्रीज और डिक्रीज as the amplitude of the modulating signal increases or decreases, but the frequency and the phase of the wave remains constant. Now in frequency modulation we will see that frequency of the carrier wave will increases or decreases as the modulating signal amplitude increases or decreases, but the amplitude of the carrier will remains constant and also its phase will remains constant. The frequency of the carrier wave increases and decreases with the modulating signal. Now in the figure you can see that EM is the maximum amplitude of the modulating signal. And the modulated wave is also shown here. You can see that where the amplitude is maximum in the modulating signal, the change in frequency, the deviation in frequency is maximum. Means amplitude is high, the frequency will also increase, and where the amplitude is low, it is in the negative side of the wave, then the frequency will decrease. And we know that time period is the reciprocal of the frequency. So amplitude increases, the frequency will increase, and the time period will decrease. And amplitude decreases, frequency decreases, but the time period will increase. Now we will discuss the frequency deviation. Frequency deviation is the change in frequency from the unmodulated carrier frequency. We know that for FM wave the modulating signal is given as x of t is equals to Em cos of 2 pi fmt. This is your signal which is to be transmitted. Unmodulated carrier is given as Ec is equals to A cos of omega ct plus phi, where omega ct represents the frequency and phi will give you the phase of the wave. The instantaneous frequency of the FM now will be given as Fi of t is equals to Fc plus Kf in x of t, where Kf is the sensitivity of the wave. Putting the value of x of t, Em cos of 2 pi fm of t, and this will be equals to Fc plus delta 2 pi delta cos of 2 pi fm of t. Now here the delta is the maximum deviation in the frequency. Now the maximum frequency will be equals to f of c is equals to f of I is equals to f of c plus delta, and the minimum frequency will be equals to f of c minus delta. We will discuss here the FM deviation ratio also. It is a very important ratio because it is described to locate the different stations in the FM. Deviation ratio is the ratio of the maximum frequency deviation to the maximum modulating frequency. Different deviation ratios are used for different applications. Music has a high maximum modulating frequency, so a high deviation is needed for good audio quality. And we know that human speech has a lower maximum modulating frequency, so lower deviation can be used. FM signals are categorized as wideband and narrowband signal. For wideband the deviation ratio will be greater or equal to 1, and for narrowband deviation ratio should be less than 1. Bandwidth of FM wave. For bandwidth of FM wave we have two formulas. Generally the bandwidth is equals to 2 into frequency of the modulating signal into the number of significant sideband, and this formula is used for narrowband in general, narrowband FM. And second is the Carson's rule, and Carson's rules bandwidth is equals to 2 into maximum deviation in frequency plus the maximum modulating frequency, and this formula is generally used for the higher wider bandwidth of FM for wider bands. Their applications are also different for wider band and for narrow band. Narrow band is generally, we have already discussed that it is used for human speech only, so it can be used for two-way communication, and the wide band can be used for the broadcasting. So frequency modulation changes the frequency of a signal to convey information, we know this. Two most common applications are the broadcasting FM radio and the two-way communications. Frequency modulating, now in this the broadcasting is you will use the wide band FM, and the two-way communication will use the narrow band FM. Frequency modulation is normally only above 30 megahertz. FM is well suited for high quality, nearly interference free transmission of speech or music, as we know that the AM wave amplitude varies, and this variation in amplitude will create noise, whereas in FM we know that the frequency varies and the amplitude remains constant, so noise can be reduced in FM. Therefore FM is better than the AM in noise reduction.